Welcome everyone to the last episode of this short video series called The Mathematics of Music. Last episode we explored the world of tuning systems in which I put into light the duality of equal temperament and just intonation. Yet I believe there is a new way to make interesting music by combining equal temperament and just intonation. One of my favorite artists, Jacob Collier, has notably already explored this topic. Thus, before I give you some insight about his techniques, let's talk a little bit about Jacob Collier. Jacob Collier is an English musician that gained notoriety on YouTube because of his intricate jazz arrangements he elaborated when he was only 17 years old. He also became very popular in the jazz community for his conscious use of complex music theory. For instance, in his vocal arrangement of the piece In the Bleak Midwinter, he decided to switch from equal temperament to just intonation. Let's listen to the excerpt. Now I will play it again, but this time try to focus on the voice that holds the word heart. If we use a tuner, a software that indicates if the song note is in tune, we see that the note Jacob Collier sings is too sharp, meaning too high according to equal temperament. That is because Jacob Collier tuned his voice by ear so that the ratios would be in just intonation. Therefore, it uses a ratio of 4/3 in his harmony instead of a 2 to the 5th power over 12, which is truer to the harmonic series. Thus, the harmony is more pleasing, and therefore just intonation can be seen as a songwriting tool that allows you to have pure harmony if that is the emotion you want to convey within your music. It can also add a ringing quality to your music, as I will demonstrate in the next segment. The Barbershop Harmony Society was founded on April 11, 1938. It aims to preserve the traditional barbershop quartet singing style, which is typically comprised of 4 male vocalists singing tight harmony, meaning that the notes they sing are very close to each other, and they often utilize a just intonation. As mentioned before, just intonation is truer to the harmonic series than equal temperament. Thus, if all 4 male vocalists sing the same vowel, like oo, ah, oh, they will have similar harmonics that will be amplified in their voice. If all the harmonics are tuned with each other because of just intonation, some harmonics will particularly be amplified, since they are the same for the 4 singers. This makes it appear as if there are more than 4 singers singing. I have an excerpt that properly depicts this phenomenon. Here it is. The extremely high note you heard, as if someone was screaming it, wasn't actually sung by any of the singers. This is just one harmonic that was amplified by all 4 of the voices. In fact, what you've heard was just a very loud harmonic. So just intonation is very important in traditional barbershop music and can be also found in modern music, like with Jacob Collier. That being said, just intonation is far from the only advanced concept Jacob Collier has cleverly used in his music. Now, this channel is intended to explore elementary music theory, but the concept I'm about to show you is way more sophisticated. Bear with me as I try to elucidate the fascinating nature of microtonality. What is microtonality? Well, it's when you subdivide notes into smaller steps. In the last episode, we started labeling notes C, C sharp, D, D sharp, etc. An octave is thus separated into 12 equidistant steps. Therefore, we say a piano is tuned to a 12-tone equal temperament. But in microtonality, there are way more notes. For instance, if we divide each step once, you get a 24-tone equal temperament system. Then, in order to find the frequency of each note, we use this formula. So we have the 24th square root of 2 instead of the 12th square root of 2. Thereupon, the note in between C and C sharp would be called C half sharp. However, microtonality is typically rarely used since the untrained musical ear can have an hard time distinguishing two notes with such proximity. Nonetheless, it is used in progressive music and in traditional non-Western music, like in this excerpt from an Indian piece. Jacob Collier has also explored the world of microtonality in the same piece that I presented earlier. This piece modulated, meaning that it changed the central note of the piece from E to G half sharp. In the next excerpt, he demonstrates that his song is no longer in 12-tone equal temperament, therefore the piano cannot fit with the music anymore.
B, yeah. 4 magical chords. And then
the notes he was playing on the piano were G and G sharp, showing that they won't fit with the song anymore since it now is in G half sharp. This modulation was achieved because this song is purely a cappella. A grand piano is restricted to the 88 notes it has. It is impossible to play frequencies in between two notes. However, the voice has no such restrictions. Next, an important facet of music theory that Jacob Collier has used is the way he tunes the note A. In the second episode, I mentioned that music was standardized so that the fundamental frequency of the note A is equal to 440 Hz. With the last episode, we know that in 12-tone equal temperament, we use this equation to then find all other frequencies. All frequencies depend on the initial frequency of A is equal to 440 Hz. But what if we take an initial frequency of 432 Hz instead of 440 Hz? Well, let's look at this excerpt. Jacob Collier has explained why he used this idea in another masterclass. He explains that elevating the central frequency gives a lifting feeling, just like a modulation does, but in a more interesting way since our ears don't expect it. Also, since 440 Hz is the frequency we're all familiar with, when we arrive to it, it's like we finally arrived home at the end of the piece. The concept of arriving home is very important in music theory. Music has two types of chords. Ones that are dissonant and ones that are consonant. In music, what we like to do is create a duality between tension and resolution. As I've mentioned before, music likes to utilize tonality, meaning that we have a central note. This note is often referred as home, since this is the home of the music. When you get to this specific note, it's like it finally resolved. The feeling is similar to when you have worked all day long, then you finally get in your car, you get to your home, and then you sit on your couch. Finally, you've arrived at home, and now you feel well. In this episode, I've showed 3 fascinating songwriting tools that musicians can use to write new interesting music. We can use just intonation, microtonality, or change the main frequency of your tuning system. I hope this helped you to understand how music works from a mathematical standpoint, and I hope you've learned something that you found interesting. Thank you all for listening. This was the Mathematics of Music.